All right, guys, I'm going to kind of do just a quick, maybe 5-minute video to go over a couple of issues I think you guys may be having. This is a continuation of 9-2, simplifying radicals. Yesterday, I didn't go over a whole lot with the cube root. Remember square root. Okay, if you don't see a number here, the index that goes here, it's assumed to be a 2. It's assumed to mean the square root. So if you see that, that means the square root of 16. It means what number times what number will give me 16? It's 4. Okay, we also went over yesterday, what happens if it's the square root of a number that's not a perfect square? Let's say 20. Well, we learned that the product rule states that I can break 20 down into two factors where one of them is a perfect square, like 4. So I break the square root of 20 down into the square root of 4 times 5. And now I know the square root of 4 is a perfect square. I can pull out the square root of 4, which is 2. I can bring it out front. So I get 2 times the square root of 5. And again, that 2 times the square root of 5 is an exact answer. It's not a rounding. It's not a decimal approximation. That's an exact answer. But what I want to go over today is a little bit on the cube root. Now, if we see that radical simple, but they have a number 3 right here, that means the index is 3. That means it's asking what is the cube root. So let's do a perfect cube. The cube root of 27, it's asking what number being multiplied by itself 3 times will give me 27. Well, think about it. 3 times 3 times 3 gives you 27. Therefore, the cube root of 27 is 3. Well, what happens if we're trying to find the cube root of a number that's not a perfect cube? Well, we do the exact same thing we do with the square roots. Let's try one of those. The cube root of 54. Before I do this problem, I do want to show you how to find the cube root in your calculator as well. Okay? If you're trying to find the cube root, we hit 3, then we hit second and the up arrow. So it's the third root of, let's do 27 and see if we get the correct answer of 3. Cube root of 27 equals 3. Okay? So let's try this one here. This example, the cube root of 54. Watch this. 3, because it's the third root. Second, the up arrow. 54 equals. Oh, wait. That's going to wind up giving me a decimal approximation. That's not what we want. We want an exact answer. So watch what we do. We're going to break down this 54 into a number that we know is a perfect cube. Well, I know 8's a perfect cube because 2 times 2 times 2 is 8. I know 27's a perfect cube because 3 times 3 times 3 is 27. So I'm actually going to break this down by using the product property. I'm going to break it down into 27 times 2. So I broke it down into 2 factors and one of them is a perfect cube. That's exactly what we want. So now I'm actually going to take the cube root of 27, which we know is 3. Since that's a perfect cube, it comes out front. And we're left with the cube root of 2. 3 times the cube root of 2. Now, if you go back and look at what we got when we did the square root of 54, look at that decimal right there. 3.77976315. I clear it out. Let's do 3 times the cube root of 2 and see what happens. 3 times the cube root of 2 equals... Oh, something's wrong. Let's try it again. The cube root of 2 times 3 equals. And you can see it's the exact same number we got when we did the square root, or the cube root of 54. Okay? Again, if we have the cube root of a fraction or square root of a fraction, Let me harp on this real quick. We also have that quotient rule. Keep in mind, so let's say we were doing the square root of 20 over 25. The quotient rule says we can break that up and do the square root of 20 over the square root of 25. The square root of 20 is not a perfect square, so I have to break that down by using the product rule into the square root of 4 times 5. I know 4 is a perfect square, so I take the square root of 4, which is 2. I bring it out front. I'm left with square root of 5 over the square root of 25 is 5. Final answer. Last thing. Let's alter the question a little bit and say that this was a 36. When I take the square root of 36, I get 6. This would not be my final answer because it's not fully reduced. This is 2 times the square root of 5 over 6. This 2 and this 6 can reduce. This becomes a 1. This becomes a 3. My final answer would be the square root of 5 over 3. Guys, it's very important that this section 9.2, simplifying radicals, you get very good at. That's why we're spending a couple days on this topic. So hopefully this video will help you finish homework 6A that's due tomorrow morning at 8 a.m. Thanks, guys.